So Michael called me and said, April 7th, there's a shuttle launch. Why don't you go down to NASA and film it? Let's see what it's like. So about a month before that, in the beginning of March, we started our talks with NASA. That went on for a couple weeks, and Richard Mosier, my first assistant, was on the phone with NASA, figuring out how we were going to turn these cameras on and off, and what were the restrictions that NASA was going to place on them. And one of the restrictions was that these cameras basically had to sit fully threaded with film, loaded and ready to go for 2 days. Because at that point, 2 days before the launch, there's a lockdown, and that was the timetable that NASA was going to give us. Well, Panavision never said to us that they didn't know if you could leave a camera plugged into a battery for 2 days if it was still going to work after the end of 2 days. So we started doing tests. Okay, let's take a camera, let's leave it plugged in for 2 days, and at the end of 2 days, let's turn it on and see if it runs. Okay, this camera runs. Okay, now let's see if it runs at 120 frames. Now let's see if it runs at 150 frames per second, which puts greater, electrical loads on the camera. So once we had worked those logistics out, then the real difficulty became, we don't never know what the weather's going to be like in Florida. Temperature on glass creates condensation. How do you leave these cameras ready to film where they go from hot, humid to rain to whatever, and then this launch happens? How do we know these lenses aren't going to get fogged? How are we going to prepare for that? So we had to build in heaters around the lenses to keep the cameras always at a consistent temperature to dry off any humidity, because we had to literally acclimatize all the gear. I was so nervous. I was not nervous that we weren't going to get the exposures right. I was nervous that the equipment was going to fail, because normally when you do a shot, you set up the camera, you check everything, you make sure the lens is clean, and you roll camera. I was going to leave 15 cameras on a launch in which I was going to get one chance at, and I had to come back 2 days later and hope they worked. And it was extraordinary. It was really, it was amazing to go out and pick up the cameras afterwards and see that they had rolled film. Now, we didn't know how the film was going to look, because we put optical flats, which are like a clear filter, in front of the cameras, because the exhaust gases, what look like that white smoke, is a combination of the heat from the engines mixing with water that is poured out of the launch tower onto the launch site, and the water's used to baffle the sound. The sound is too loud, was actually shaking the tiles off the space shuttle. So they found if they dumped 9 million gallons of water throughout the launch on the orbiter as it launched, it would deaden the sound. But what happens is that water mixes with the hot gas from the engines and produces incredibly strong hydrochloric acid gas. So you have to wait 4 hours before you can go even near the cameras after the launch has gone off. There's like a 4-mile area that's just locked down, and you can't go there until they go out there with their meters and say it's now clear. The first time we went out there, 2 of my camera assistants got out to the first camera and just started throwing up, because the smell of the gas was so noxious. They just puked. They literally were down on their hands and knees throwing up. And we took the cameras out and sent them back, sent the film to the lab, and it was just spectacular. So having been able to pull off a day launch, and having the way that we worked with NASA having went off so well without a hitch, we later went back and asked NASA, okay, in 2 months, in June, you're doing a night launch. We want to film the night launch as well. And NASA agreed. And we went back, and on the night launch, we even pushed it a little farther, and they allowed us to put 2 cameras on the actual launch pad itself, which was quite an experience. Because when we put the camera in the special box on the launch pad, they said to us, this camera is going to experience 25 Gs of energy when the motor gets above the camera and shoots down onto it. And when we got after the launch, when we went to take the camera out of the box, the lens had actually vibrated loose, that all of the elements of the lens had fallen apart. Every single screw had backed out of the lens. We picked up all the pieces and put them in a box and sent them back to Panavision. They put the lens back together, and it was fine. But the energy was such that it had literally shaken the lens apart. This is actually the camera that gets shaken apart right here. As it goes up, that camera that you just saw, and you'll see it again, is only about 8 feet away from the orbiter. This run right here, I mean, this thing gets just pounded. The thrust coming out of there is quite extraordinary. Some of these cameras, the ones that were not on the gantry were, this is about 200 yards away. This is 50 yards away. This is IMO from the roof of the vehicle assembly building. It was like the 16th camera I had. I had one extra camera, and I stuck it up there. This is, I mean, I had 15 cameras running, and every single one is like, how do you choose which one to use? They were all spectacular. There's not one piece of NASA stock footage in here of a launch. This was all stuff that I did. See the fish jumping in the right-hand corner? It got so bright that the fish could see the insects, and they start jumping out of the water and feeding.